Okay, so today we're going to do 2 to 1 here. And when I talk about 2 to 1, it doesn't matter which one is 2 and which one's 1. It's just that you have in this case, you have a plus 2 and a negative 1. And you could also have a plus 1 and a negative 2, and you would just have 2 here. The idea is that you have 3 total ions. In this case, you have 1 positive ion and 2 negative ions. I'll just show you that. You know that magnesium has 2 valence electrons, loses both. Then you got fluorine, negative 1, becomes a fluoride, and so that balances out. So that's what we're looking for there. So when you get this, we're given a molar solubility, and so that molar solubility goes for each of the ions, and we have to account for the fact that there's going to be twice as much of the fluoride, and that the fluoride, when you write the KSP, is also going to be squared. Okay, so we're going to sit on that molar solubility there for a second, and I'm just going to write a KSP statement here. Now remember that the magnesium fluoride's a solid, so the denominator just drops right out. And so I've got Mg plus 2, and I've got F minus, like that. Okay, so there's my KSP statement. And then if I want to talk about that molar solubility, that's the molar solubility we can assign here, but it's going to be twice as much here, 2 times that, because for every 1 magnesium, you get 2 fluorides, okay? So I'm going to actually show you this. You could look at it a couple of different ways. I think the easiest way to look at it is an X, and then 2X. And so I look here, that helps me remember that I get 2 of those fluorides, and then that's going to be squared. And so if I work all that out, we're going to have 4x squared, multiply it by the first x, and you have 4x cubed. Okay? And so that breaks it down really easy. So that molar solubility will plug right in there for x. And so it's going to be 4 times 2.7 times 10 to the negative 3 cubed. Now, you got to remember, I've heard it called a bunch of different things, but I think I've always heard it called PEMDAS. Okay? Parentheses, exponents, multiplication, division, addition, subtraction. And so one of the mistakes you could make here is going 4 times this and then raise it to the cube root, or cube power. Cube roots go in the other direction. So what I'm going to do is go 2.7 times 10 caret negative 3, and the caret just makes the exponent. That's just something I will say. So I know that I'm doing it. I'm just going to equal that, raise it to a cube, and I get like basically 2 times 10 to the negative 8, and then multiply that by 4, and I get 7.8732, like that. But since my original number had 2 sig figs, right here, 2.7, I'm going to round that 7.87 to 7.9 times 10 to the negative 8, and that is your answer, and that's how you do one of these simply. Now, the other way you could approach it is you could, and I'm just going to do it down here in the corner, so it might be a little small. KSP, Mg plus 2 f minus squared, and then there's no way this is happening. You just put that 2.7 times 10 to the negative 3, and then you go 2 times 2.7 times 10 to the negative 3, like that. I like doing it with x's better, but you could plug in here and plug in that 2.7 times 10 to the negative 3, and then 2 times 2.7 times 10 to the negative 3, square it, and then multiply them together. I think this is quicker, honestly.